People have wondered, I'm sure, and if you're watching this particular video, you are one of them, why does she factor like that? Now, I know that a lot of you have these X's that you draw and you put numbers here and here, and then there's some little tricks. In some cases, like you might put something here and then you divide and then you simplify. I'm going to show you, here's the reason that I don't factor like that. Over the years, I have found that there are lots and lots of factor tricks like that look similar but that are different. And so a lot of times students have to relearn a different method every year. And also, students tend to not remember what you put where and when, or get it confused. So I'm going to show you why I factor the way that I do, and I will go ahead and tell you it's because when you factor this way, you are doing exactly, mathematically, a true statement. Okay, so I'm going to start out the way most people do factor, and it's the correct. It's parts of it I am with you on. Typically, a lot of people write, okay, you're looking for numbers that multiply to, and what you do is multiply that 6 and the -5. So you know that you're looking for two numbers that multiply to give you -30, which is 6 times -5. And then they add to give you that number in the middle, -13. All right. I'm going to assume you might have some guesses, but you might also be wrong. So this is how I look at a factor list. I just go ahead and make a factor list, all right, and try to figure out what are the factors of that -30. So I start with 1. 1 times 30 is equal to 30, and then I go on to 2. 2 times 15 is equal to 30. Then I go on to 3. 3 times 10 is equal to 30. 4. Okay, 4 doesn't work. 4 does not go evenly into 30, so I'm going to mark through that. 5 is 5 times 6 equals 30. 6 is 6 times 5. Now, as soon as you start to see factors you've already listed, but they're reversed, you can stop. Okay, you don't have to go any further because what you have is an already complete list up above that. So I'm looking for numbers, one of these 4 sets of factors, that multiply to give me -30, but add to give me -13. I know it's not that one because there's no way that 30 and 1 could add or subtract. You might think it would be -3 and -10 because those do add to -13. But notice 2 negatives adding to -13. If you multiplied those, you would end up with a +30. And that's not what you have. You have a -30. So the only way you could get a 13 with 3 and 10 is if they were the same sign. The only way you're going to get a -30 is if they're different. So it's not the 3 times 10. Let's look at the 15. If you did 15 times 2, you would get a 30. If you did a -15 times 2, you would get a -13. Okay? Now, I want you to watch what I'm going to do here. It's not complicated at all. And you literally, in math, and especially in algebra, remember you just write a true statement from step to step. Anytime you go off to the side and do like tricks, you stand a likelihood of making an error. So I'm going to look at this. 6x squared minus 13x minus 5. I'm going to rewrite that as 6x squared here. Now, I'm going to rewrite -13x as 2 factors, and that would be -15x and +2x. And where did I choose them? I chose them from right there. 6x squared minus 15x plus 2x. -15x plus 2x is exactly the same thing as 13x. I have not changed this expression that I was given. And then I do the -5. Okay? So, the reason that I do this is I can now pair these as if they are binomials. And what I'm looking for is common factors for each pair. So if I look, I can tell in this first pair, if I pull an x out, well, I can pull an x out, and I know that 6 and 15 both have a common factor of 3. So if I pull a 3x out, what I end up with is a 2x minus, and 3x into -15x is 5, okay, plus, and I'm going to look right here, 2x minus 5, they do not share an x, and they share only a factor of 1, no other or no larger factor. So you're going to take 1 out of that, and you end up with 2x minus 5. So you'll notice that something kind of interesting happened right there, where I ended up, and this will always happen this way, where you end up with a common, if it's factorable, you'll end up with a common binomial. Okay, I'm going to leave this for just a second, and I want to go down here and do a spoiler alert. The answer is going to be 2x minus 5, but I want to track what happens. Keep in mind that when you're multiplying out, and some teachers may call this FOIL, but all that is multiplying this binomial times each term. So you multiply the entire binomial 2x plus 5 to each term of 3x minus 1. So you're going to do 3x times the binomial 2x plus 5. I have distributed it across. So you can distribute a binomial across another binomial. And then 3x minus 1 times the 2x plus 5 would have to be applied to that one too. All right? So all I did was take 2x plus 5, multiplied it by that, then multiplied it by that. Okay? Now then, you would just distribute 3x to both of those terms. Okay, so that would be 6x squared plus 15x, and distribute a negative 1 to both of those. So that would be minus 2x minus 5. Now the reason that I bring that up, 6x squared plus 15x minus 2x minus 5, is go back up here and look. 6x squared minus 15x plus 2x minus 5. Okay, right there. And look at the step, you're doing just the opposite here. You pull common factors out, which would be this step right here, which means what I'm trying to do is get back to this step when I'm factoring. So this is multiplication, which you do by distribution. This is the same as almost like division, okay, which you do when you're factoring. So what you're trying to do is undistribute a binomial to both terms. So if you take 2x minus 5 from both of those terms, you would end up with 3x plus 1. And now it's factored. Okay? So I like this method because I don't have to figure out what to put where. I just write true statements.